Today we're doing P6 Day 1 Rational Expressions, and your learning goal is for you to be able to find or exclude numbers from the domain, simplify, multiply, and divide rational expressions. Okay, so that should be exclude numbers from the domain. I took out find. All right, so let's start by what is a rational expression. A rational expression is an expression that can be written as a fraction. And because of that, we know the rule is we must exclude numbers from the domain that will make your denominator 0. So for example, here's my rational expression. And if you look at what numbers would make your domain or your denominator 0, that would mean that x would have to be equal to 2. So when we exclude it, we just say x cannot equal 2. Because if it is 2, you divide by 2 minus 2 is 0. If you divide by 0, then it's undefined. Okay, so let's do another one. Okay, in this case, I'm going to factor it, because sometimes you have to do that. There are two x values that will make your denominator 0, 1 and negative 1. So we have to exclude those. So x can equal 1 and it can equal negative 1. Now, if you there are cases where there isn't any number that will make it 0. So in that case, there won't be any that works. Let's try another one. So in this example, you have to factor it. So this will be x plus 9, x minus 5. So here's another example of two x's that will make your denominator 0. So x cannot equal negative 9 or 5. So that's how you exclude numbers from your domain. Okay, we are going to simplify rational expressions, meaning that you're going to factor the numerator and denominator completely and divide by any common factors. So you always factor first, and we say factor and cancel. That's the rule. So I'm going to start with x cubed plus x squared over x plus 1. So factoring the numerator, I'm going to take out an x squared because that's GCF. Before you cancel, write your numbers that will, or exclude numbers in your denominator that will make it 0. So here x can't equal negative 1. Then you divide that equals 1. So my answer is x squared. So factor, exclude your, or find the numbers that will be excluded from your domain. Then you divide and cancel. Here's my second example. This example I have to factor both the top and the bottom. So those of you all that are good at factoring, Okay, so I'm going to exclude my numbers in my domain. So x cannot equal -5 or 5, just the denominators. Then I'm going to divide those, and my answer is x plus 1 over x minus 5. Okay, now we're going to multiply and divide rational expressions. Very important. You want to factor completely your numerator, all your numerators, all your denominators before you multiply. So I'm going to factor each one. So I'm going to do my numerator first, then my denominator on the left side, then the numerator over here, and then my denominator. And we're dividing. So this divides to equal 1. This divides to equal 1. This divides to equal 1. And then you're only left with x minus 1 over x plus 2. And then that's your answer. You can never cancel numerator and numerator. You can only go from the numerator to the denominator. Alright, let's try another one. Okay, my left side I'm going to factor the numerator. The denominator, that's a perfect cube, so I have to use SOPs. S-O-P-S. Square the first term, opposite sign, product, square the last term. Okay, so I'm going to divide. This divides the 1. This divides the 1. So the only thing that's left is 1 over x squared minus 3x plus 9. And then you're done. So factor every term completely, and then you can divide it out. Don't forget to write your exclusions. So in the first problem, x cannot equal, so you got 3, -1, -2, and 2. And then this one, x cannot equal -3. We can't do anything to that one. And that's it. Division is a little different because we're going to use a process called keep, change, flip. What that means is you're going to keep the first fraction like it is, but I'm going to go ahead and factor it. Factor everything completely. Then you change your division to multiplication. That's supposed to be keep, change, flip. And in the second fraction, you're going to actually flip it. That means do the reciprocal. So after you flip it, then you can factor it. So then you divide. This divides equals 1. This divides equals 1. This divides equals 1. This divides equals 1. So my answer is 1. Don't forget your exclusions on this example as well. So x cannot equal -5, 2, -2, -3, and even the ones we flipped, they're covered in my list, so I'm okay. Okay, this last example, I'm going to do multiplication and division together so you can see how that looks. So for the first example, I'm going to, or the first two fractions, I'm going to go ahead and factor it. And I'm going to do it by GCF with my numerators. Then my denominator, I'm just going to factor this trinomial. With the division, I'm going to do keep, change, flip. So change is the multiplication, and flip this fraction. And then this factor and this one can go further because that's a difference of squares. And I'm going to do GCF with these two terms. And before I cancel, let me write my exclusions. X cannot equal 0, 5, 1. This is 0, -5. And then the one we flipped, -1. Okay, so those are all my exclusions. Now I can divide them out. This x and this x will divide out. These two terms will divide out. These two terms will divide out. These two terms will divide. 2 can divide into 4 twice. And then we write what's left. So I have a 7 left on the top and an x plus 1 squared. And then on the bottom I have a 2x squared. And that's it. And then we're done.